Service oriented architecture and microservices are some of the most popular trends of our industry. At some point, it seems that almost everyone is advocating for these architectural approaches and their benefits. And the reasons for their popularity often centered around two key assumptions. Services are strongly decoupled from each other and they support independent development and deployment. Let's challenge these assumptions because what is popular is not always relevant. Sometimes the popularity is because of some other factors other than the most highlighted one. So, we will begin by challenging the notion of calling services as an architecture itself. And for that, we have an interesting reference in the Clean Architecture book of Robert Martin, too. So, Robert Martin says that the architecture of a system is defined by boundaries that separate high level policy from low level detail and follow the dependency rule, which means the high level view that you have in your mind about your software architecture. When you separate that from the implementation details through boundaries that follow the dependency rule, that defines your architecture. So, where does services stand in this high level view? Nowhere. The services that simply separate application behavior are little more expensive function calls and are not necessarily significant. So the point is, we does not mean that all services should be architecturally significant, or we are not making a point that services are not architecturally significant at all. But services in and of themselves do not define an architecture. That's the key point. And as Robert Martin perfectly put, services are, after all, just function calls across processes and or platform boundaries. Some of those services are architecturally significant and some are not. Now let's talk about the most highlighted service architecture benefits. One of the most talked about architectural benefit of breaking a system into services is that services are strongly decoupled from each other. After all, they run in separate process or even a separate processor, and therefore they do not have access to each other's data. And the interface of each services for that purpose must be well defined. That's the most popular argument about the service oriented architecture or the microservices. Well, there is some truth in this, but only some, not very much. Yes, services are decoupled at the level of individual variables, but they are still coupled by shared resources within a processor or on the network, and sometimes they are highly coupled by the data they share too. And as far as their interface is concerned, yes, one can define them well. So do one can define well their function interfaces as well. Now, how one is going to define an interface cannot be cited as an internal benefit of services. So, in a nutshell, this overhype about decoupling as a benefit often create an illusion. The reality is different. There's a similar kind of policy of independent development and deployment as well. It is often said that one of the benefits of arranging everything around services is that these services can be operated by DevOps teams as part of your DevOps strategy, and that helps in independent development and scalable deployment. Well, if you look at the history of enterprise system, and as Robert Martin also rightly highlighted, we will find that some of the large enterprise systems can be built from monoliths and component based systems. And services are not the only option for developing the scalable systems. And services cannot always be independently developed, deployed, and operated. as we have already discussed. Sometimes they are coupled by data, and then their development, deployment, and operation must be coordinated. So, in a nutshell, the problem of coupling and coordination is a natural part of a software development process, and it is always going to be there with or without services. Now, the question comes then what's the solution? On that, Robert Martin suggests, and he being the propagator of the solid design principle, he said that we must make things as clean and as simple as possible. And that we can do with the help of solid design principles. We can create a set of classes that could then polymorphically be extended to handle new features. So you can ask that can we use the solid design principle for services? Yes, we can. Services can be designed using the solid principles and then can be given a component structure so that new components can be added to them without changing the existing components within the service. And finally, we can conclude that services are indeed useful for scalability and developability of a system, but they are in and of themselves not architecturally significant elements. Architecture of a system defined by boundaries and by dependencies that cross those boundaries. So, having services in your architecture design can help, but building software architecture by keeping the services in center only for the sake of using the services is not a right choice and a right approach.